Here's example number 2. A red curling rock traveling straight down a sheet of ice at 0.42 meters per second contacts a stationary blue rock. After contact, the blue rock moves at 0.18 meters per second at an angle 65 degrees north of east. The red rock moves at an angle 25 degrees south of east. The mass of the curling rock is 18.5 kilograms. Determine the speed of the red rock after the collision. This is one of those glancing type where the objects come in, one of them may be in a velocity, the other one stationary, or they both may be at velocities, but they're going to hit, move off in their own direction, and at their own speeds after. This is the one that requires quite a bit of work and a lot of organization. I've got kind of a little flash animation to kind of demo this and to show you our components in this example. So have a quick look at this play through. There's our rock coming in. After the collision, they move off in different directions. The blue rock moved off at 65 degrees north of east, and we need to break that momentum into its X and Y component. The red rock moved off at 25 degrees south of east, and we need to break that into its X and Y components. So we're going to have a couple X's and a couple Y's for each object so that we could go and figure out that velocity. What we're going to need to do is figure out the resulting momentums so that we can get that resulting velocity. Play it one more time and then we'll go to the actual question. Okay, so in the diagram here, what I've set up is our before and after, and what we're going to do is label all our information. First of all, we know the mass of the rock is 18.5, so let's label each mass 18.5 kilograms. There's one piece of information. And I'm not even going to use the prime or anything like that. Mass is conserved throughout. The mass of the curling rock is the same before and after. The red curling rock is traveling down at 0.42 meters per second. So now we know its velocity of object 1, 0.42 meters per second. The velocity of object 2 is stationary, so it's 0 meters per second. After contact, the blue rock moves off at 0.18 meters per second. So let's put that velocity after 0.18 meters per second. We've labeled the angle 65 degrees north of east. Red rock 25 degrees south of east. What we want is we want to figure out what the velocity of object 1 is after the collision. There's our unknown. So there's all the information that we were given, and there's our piece of information we need to find. Now, what we need to do in here is to do a little bit of thinking to figure out how are we going to work our components. When you look at the before scenario, the momentum of object 1 is strictly in the X direction. The momentum of object 2, there isn't any. In fact, we can label that very quickly. Momentum of object 2 before is going to equal to 0 kilogram meters per second. So our total momentum before will only be in X, and it'll be to the right in this case. Well, let's multiply the 18.5 times 0.42 to give us 7.77. Momentum of object 1, 7.77 kilogram meters per second. I'm going to choose that direction to the right as now being positive. Any direction to the left will be negative. So I now know at the beginning here that the total momentum in the x direction is going to equal to 7.77 kilogram meters per second before, which means that has to equal to the total momentum in the x direction after. The total momentum in the y direction before is 0 kilogram meters per second. So that must mean that the total momentum in the y direction after has to always equal to 0. So that means if I could find one of those y components in the after, that means the other has to be equal and opposite to make 0. Right? To make 0, they have to be opposite numbers. Well, since I have all the information of object 2, I'm going to go and find the momentum and the two components for object 2. And I'm going to put my long calculations out on the next slide, but I'm going to try and do as much on this slide while you're copying it down, and then I'll put my example of these and show their longhand form after. So what we want to do is we want to find this momentum of object 2 after in the x direction, and this momentum of object 2 in the y direction after. We can find its components because what we can do is we can find its resulting momentum by just multiplying mv. The resultant is going to be 18.5 times 0.18, which is 3.33 kilogram meters per second. So now that I have the resultant, now that I have an angle, I should be able to find the x and y component using trig. Now before I get too far ahead of myself, I'm going to show how I calculated momentum of object 1 before right now. And then I'm going to do the components of object 2 after. So the first thing we'll do is we'll write momentum of object 1 before equals mass of object 1 times velocity of object 1. Put our numbers in. I think it was 18.5 times 0.42, 18.5 kilograms times 0.42 meters per second, and we have a momentum of object 1 7.77 kilogram meters per second. I'm not going to show that second calculation because that was just an MV, but I am going to redraw this diagram out so that it'll help me find its components, and then I will come back and look at what else I can do to help me find information for object 1. So I'm going to take object 2 here and draw out that triangle a little bit bigger. 65 degrees was our angle, and what we want to do is we want to break it into its x and y components. So we were given a 65 degree angle, we were given 3.3 kilogram meters per second was its resulting momentum. And what we want to know is the momentum of object 2 in the y direction after, the momentum of object 2 in the x direction after. Well, we can use our trig to figure that out. Sine 65 degrees will equal opposite momentum of object 2 in the y direction after divided by 3.3 kilogram meters per second. So this is a lot of work, but it isn't complicated work as long as you stay organized. So we can find that the y component turns out to be 3.02 kilogram meters per second. The x component is now going to be cos 65 degrees equals P2 in the x direction after over 3.3 kilogram meters per second. And the x component is going to equal to 1.39 kilogram meters per second. And the x direction is heading to the right. I'm going to label that as positive. The y direction is heading up. I'm going to label that as positive. Now I'm going to go back to my diagram and put this information so that I don't forget where it came from. So let's go back to our diagram and label this. P2x after turned out to be 1.39 kilogram meters per second. P2y after turned out to be 3.02 kilogram meters per second. Here's a little piece of advice which you're always going to do. Whenever you see things at angles, you're going to find all its components every single time. So you find the resulting from trig, you find the x and y component, just like we were doing with forces back in the review. So object 2 is done. So what? Now what we need to do is our little bit of thinking here and realize, can I use that to find the resulting momentum of object 1 after? And if I can, then I should be able to find the momentum of object 1 in the x direction and the momentum of object 1 in the y direction. And then I can use that to find all my pieces. Now think about this for a second. Total momentum before in the y direction was 0. That means total momentum in the y direction after must be 0. So that means that if the momentum of object 2 in the y direction is positive 3.02, the momentum of object 1 must be negative 3.02 kilogram meters per second. That way when you add those two values, you get 0 after, you get 0 before. That also makes sense according to our diagram, because if you break object 1 into its components, you will see that, yeah, I have a horizontal component to the right, but I have a vertical component down. So it should be an opposite sign. I also know that the total momentum in the x direction has to add to 7.77. So if I've got 1.39 accounted for, 7.77 minus that 1.395 should leave me with 6.375. I guess I should go 6.38 kilogram meters per second in the x direction. 6.38 plus 1.39 should give me 7.77. That's according to our conservation law. We have to have total momentum before equals total momentum after. Which now tells me I can use Pythagoras' theorem to find the resulting momentum. Notice I broke the one object using the resultant into components, used the components to figure out the momentum of the other object resultant. Then I can find its velocity. Lots of work, lots of calculations. First of all, I'm going to show how I got the 6.38, etc., etc. Since we know that the total momentum in the y direction equals 0, then we can write, therefore, momentum of object 1 in the y direction after is equal to negative 3.02 kilogram meters per second. We also know that the momentum in the x direction is going to equal to 7.77 kilogram meters per second. Therefore, the momentum of object 1 in the x direction is going to equal to 7.77 kilogram meters per second, subtract 1.39 kilogram meters per second, and we get the momentum of object 1 in the x direction equal to 6.38 kilogram meters per second. So that's the calculations that we just worked out on the other slide. Now that we have an x and y component for object 1, we have an angle, we can use Pythagoras' theorem to find that resulting momentum. So therefore the momentum of object 1 is going to equal to negative 3.02 kilogram meters per second squared, I'm using Pythagoras' theorem, plus 6.38 kilogram meters per second squared. Take the square root of the result, and the resulting momentum, 6.38 squared plus 3.02 squared, take the square root, you get 7.05 kilogram meters per second. Still not done, because we also know that momentum of object 1 after will be the mass of 1 times the velocity of 1 after. So the velocity of object 1 after will be equal to momentum of object 1 divided by mass of 1. Put the numbers in. 7.05 kilogram meters per second divided by 18.5 kilograms, and you finally get, after many calculations, a final speed of 0.38 meters per second. You can state the direction, but we already know what it is. You don't have to figure this out. 25 degrees based on our picture south of east. So you don't have to work out the angle, because this time you were given it. You have to find the velocity. Lots and lots of trig involved in this. Lots of understanding components. Every time you're at an angle, break it into its x and y components to find the resulting. Remember, you conserve the components before and after. Do not conserve the resultants, conserve the components. Organization is what's key to making this work. These are the most lengthy problems in Physics 30. The formulas are not difficult. It's the matter of coming up with a very detailed step-by-step approach. And once you understand the how to do this with all the different types, you just repeat it, repeat it, repeat it. So our final answer, 0.38, 25 degrees south of east.